sequence is a set of numbers that follow a sequence is a set of numbers that follow particular rule. All right? Rule or pattern. That's point number one. Point number two. Each number in this sequence is called a term. By the way, before I continue, see? Let me give you an example of what we're talking about, right? And you guys would have worked questions like this in CSEC. Like you have it's just a set of numbers. 147 and 13. And it goes on and on. Usually questions says find the missing numbers, that's true. You know those questions? You get a series of numbers and you're asked to find the rest of numbers. By the way, what the next number would be in this sequence?
16. 16,
Okay.
sir.
Come on. Yes. Because it's going up by, you keep on adding what? 3. Not true. 1 plus 3 give 4. 4 plus 3 give 7. 7 plus 3 give 10. You follow? So the other one would be, the other term would be 16. Alright, so each number is called a what? Term. Now, sequence can either be finite or infinite. Finite series mean the number goes on and on and on, that's true. And no, sorry, a finite series means that the numbers they stop. Sorry. They stop somewhere. An infinite series means that what? It goes on and on and on. No, a series no, not series, guys. Sorry, I keep on doing that. Keep on mixing up those two words. By the way, those two words are different, you know. A series is different from a sequence. So those are not similar words, they're different. So a sequence can have a recursive relation. Recursive, the word recursive, you can get recurring from that, not true? It means that it goes up and down, up and down, up and down. You know, like it's, for example, you start off with one number, like say 3, 10, 5, and then you go 3, 10, 5 again, and then 3, 10. It's like it keep on repeating. All right, so let's get into the mathematical aspect of it. But one more thing. A sequence can be convergent or divergent. Or periodic. No, convergent means converge, the truth. It means that they all come to a point and end. All right. So it's like converge will be like a funnel or a filter paper. You know what a filter paper is? A filter funnel. You guys know what a filter funnel is? Right. So the filter funnel, it starts at the top, open, and then it narrows down. Not true. So you'd say by pouring water, you'd say the water converges through the filter funnel. If you flip around the filter funnel, you'd say it's divergent. You know, so it's like if you pour water at the narrow part, it comes out wider. And a sequence can be periodic. No, periodic and recursive actually, they're very similar in terms of definition. All right. Okay. So let me just run this again. A sequence is a set of what? Numbers that follow a particular rule or pattern. Each number in the sequence is called a what? A term. A sequence can either be what? Finite or infinite. Finite means it stops somewhere. For example, if I say all even numbers between 1 and 10, that's finite, not true. If I say all even numbers or all the prime numbers greater than 20, and stop right there, it will go on and on and on. That will be infinite. A sequence can have a recursive relationship. Recursive means that it goes up, it goes up. It's keep on flipping. You know. For example, you might have 1, 2, 3, and then you have 1, 2, 3 again, and it's very similar to this word here, periodic. All right. Any questions? All right. All right, let's look at an example. I'm using curly brackets here. All right. So just write down the first 6 terms in the sequence defined by the recursive relation. All right, so the recursive relation, so this is the recursive relation. All right, now an an represents the term. So for example, in this sequence here, an would have been 1, not true? All right, let me just write something here. Let's look at this sequence. An, well, A1 would be 1, all right, and A2 equal what? 4. You guys follow? etc. All right, and n start at 0, 1, 2, 3, etc. You follow? So remember now, 1, 4, 7, and 10 and 13 are terms, right? But A represents what? The first term, and it represents the first term because it's called A1, and A2 will be 4, A3 will be what? 7. All right. So in general, we call it the nth term. All right, or we say the nth term. The nth term. All right. Any questions? All right. Sasha, any questions?
Sorry.
Yes, come on.
If power say about the A2 equal 4, we can ask for the part.
All right. So remember, n starts at 0. It's an, you know. All right, and an represents the nth term in the sequence. So so A, because 1 is the first term, it's called A1. So A1 is equal to 1, and A2 is equal to 4. So A2 would have been the second term in the sequence.
Oh, so
Yeah.
it,
Let me tell you, it's just easy. It's easy for me to say, boy, second term of 4 and the third number is 7. But what they do, they give it a little a special thing. They call it A subscript N. You follow?
yes, sir.
So 1, 2, 3, 4. So what is A5? A5 will be equal to what? 13.
13.
Because it's a fifth number. Alright? Alright. Alright, so please write this off. And this is a sequence from up top here. What if I can put it up there? You know, I'm not gonna erase it. Alright, so now we want to write down the first 6 terms in the sequence. Now what is this? This is just the heading. So sequence is equal to AN. So your answer, what you're gonna do is it. So basically, guys, you're gonna have a number there, a number there, a number there, etc., etc. So our job is to find the numbers. So all we need to do is to put n equals 0 in this formula. That's all we need to do. So n, when n is equal to 0, we're gonna have a subscript 0. That's equal to 1 plus 3, and that's what? Oh guys, sorry, n is not equal to 0, Sorry. N starts at 1 here. Sorry about that. N starts at 1. You know why it can't be 0? Can someone tell me why it can't be 0?
Sir. The 0 is not in the sequence number.
Exactly, because there's no 0th term. It's just the first, the second, and the third. All right. Unless you're gonna rename a series and say, okay, you have the 0th term, then the 1 term, then the 2 term. You're so correct, Carlos. There's no 0th term here. It's just the first, so the 1 is actually the first term. All right. All right. So n is equal to 1, right? So a1, and the 1 is the first term. Well, let me say this now. 1 is not really the actual first term. Like it's not actually 1. It could be any number. All right. So we have 1, subtract 1. All right, and 1 from 1 will give us 0. 3 times 0 will give us 0. So all of that will go away, leaving what? Leaving 1. So what's our first term in this sequence here?
Sir.
Yeah.
I have a question. Me did kind of lost there, because I'm saying like you know work out what's in the bracket first, and then you add 1 plus 3 to get, well, when I work out that, I got 0 as the answer.
No man, I must say no.
Sorry, maybe not the one up front right here, so. Right here, so when you see 1 plus 3, maybe not add that the one there. Yeah.
Travis, I forgot that there's a 1 in front of it.
Well, sir, me basically add the 1 plus the 3 to get the 4, and then me work away in a bracket.
Yeah, but Travis, what is 1 from 1?
Oh, 0.
Yeah, what's
0.
What's 3 times 0? 0. So 1 plus 0. I'll give 1. Remember, I always wrote the bracket first, bad maths.
Oh.
Alright.
Well, sir, that me actually do what it seems like. Me say after my work away in a bracket and get 0, sir. My mind I tell me say 1 plus 3. And get the 4.
Okay. Alright. N now is equal to what? 2, not true. So out of the 6 terms, guys, how much we got? 1, not true. So we want to write we want to get the second term now. So let's call it A2. And A2 means that we're just going to use a recursive relation and replace n with equal to 2. That's what I'm doing. So A2 is, remember, this is the relationship that we're using. Remember that a sequence follows a what? A pattern or a formula, not true? And this is the relationship. Alright? So we have 1 plus 3. N now is what? N now is 2. So it's 2 subtract 1. Alright? And then that's going to be 1 plus 3. 1 from 2 in the bracket gives you 1, not 2. Right? So we have 1 plus 3 1s is 3. So therefore 1 plus 3 is equal to what? 4. So a second term is what? 4. Alright? Are you guys following?
Yes, sir.
Yes, sir.
Alright, what I want you to do is to work out the rest of it. So the third, the fourth, the fifth, and the sixth term.
Sir,
Yeah, bud.
it come like at the same answer what they are top. Okay, third one we'll find a 7.
Oh. Okay. So you got 7?
Yes, sir.
What's the other one?
10, same way.
10. And 30, not true?
Yes, sir.
And this turns out to be what? 16?
16.
I went this week. You had to say I go on vacation already. Fish. Just last week, Friday. Really, like factor 6 still. I think so. I wasn't expecting that. I'm gonna do that. Oh my, oh I shot for it.
Alright, guys. Everybody get that?
Yes, sir.
Alright. Let's look at another recursive relationship. Let's look at a few actually. Boy, typing these things don't are very difficult. I don't know. All right, so okay, so question 2. Let me make it a little bit easy. Rather than go to 6, just use 5. All right, you wanna kind of stay away, guys. You know. All right, so let me see if I can work out the first one for you. So this is the recursive relationship. It's different from the first one. It's a total different. So n is equal to what? 1. So our job now is to our job is to work. We want to fill out. We want to put in those numbers, right? And we want to write on the first number, the first 5 numbers. So we start out with n equals 1. So you're gonna replace n equal to 0. All right. So we're gonna have no, sorry, not n equal to 0. N equal 1. I keep on saying 0. You know why I keep on saying 0? I always start out from 0. So A1 is equal to 3 times 2 to the 1. 1, because n is 1, subtract 1. Everybody see that?
Yes, sir.
Alright, and then now, please remember, don't say 3 times 2. Work out the power first. Alright? So it's gonna be 3 times 2 raised to what?
0.
Oh, not true. And then no, that's 3. That's 3 times what's 2 to the
Times
0?
1.
1. 2 to the 0 is 1, not true? Because any number raised to the 0 is equal to 1. So therefore 3 ones is equal to what? 3.
3.
So the first term is 3. You guys follow? So to get A2 now,
Yes,
to get A2 now, just replace n with what? 2. Alright, do me a favor and work out the other 4 terms for me. You guys have a scientific calculator? You need to get one here. So get one. You know, if you don't have any knowledge, it's okay. But you don't. If you have one, let's draw it close to you. All right, guys. I'm gonna. Oh boy, anything something. Can I stop sharing the screen? I need to go to another class just to submit a work. All right. So while I'm gonna stop sharing. Okay. Anybody
okay,
write?
sir.
Yeah. I need to post a work. All right, guys. All right. What's the other one? What's the other term? What's the second term? Class?
So as me getting a sir.
Yeah, man, a 6-1. You're right. What's the other one?
Then 12,
12.
24, and 48.
Go on,
24 and 48. Yes, it's correct. Very good. Everybody follow?
yes,
Everybody get
everybody
out?
follow.
No, you can't. Yeah,
Yes, sir,
I'm
we can't say that.
you can't. I'm never said that. I'm never ask that. So in class now. Alicia, are you following? Jamila, are you following?
Yes, sir.
Cunningham?
Sir, me tell you already, so me
Yes, sir.
can't see your screen, so I wonder if you could when you finish, you just send me something.
Oh, you're unable to see the screen. All right. Okay, so I will send the recording. All right. Let me tell you something. Let me tell you, not all of my recordings I'm gonna put it on YouTube here. Sometimes I'm gonna put it in stream because they actually give us a link for this video recording on Google Meets. All right. Because sometimes to put it on YouTube takes a lot of effort. All right. Let's look at a few more. Let's look at another one. All right, do one for me. Find the first 5 terms. And start off with n equal 1. All right, so I'm gonna put some more there. All right, guys. Number 3. Any takers? What's the first term?
Sir, I get 5.
Yeah, man, 5. What? Anybody can tell me the other one?
3.
All right. Apart from Travis, anybody can input the third term? Kemar?
Sorry, you know, say my one look kind of confusing, though, but it's like getting out.
What's the third term? What you got? All right. Anybody else? Brianna?
Sir, you want me to continue?
Hold on, Travis. Alicia? Jamelia?
Yes, wait, sir, we don't finish yet.
All right. Shamari?
Sir, me still a work it out.
All right. You mean number 3? Number 3 talk about, you know? All right. I'm going to show you this one here.
I bought 6 Tiffany minutes of first reading English blue.
Sir. Sorry.
Yes.
Sorry, and the third one, I don't know if I'm wrong, but I won.
Yeah, man, I won. Anybody record that out? The third one? The fourth one? Travis, what you get?
Sir, me get -1.
Yeah, it's -1. What's the last one, Travis?
Last one, -3.
Right, very good.
Oh yeah, sure.
All right, okay. Now notice that I put dot after it, right? You don't end it up abruptly because it's not a finite series. You follow? So you don't close it. You put dot to mean that it goes on. All right. All right. Any questions so far about these numbers here? Anybody lost?
No, sir.
Okay. All right. You're saying something, Travis?
Yeah, I'm just saying that I understand.
Okay. All right. Anybody else? Can I move on to question number 4? All right. So question number 4 is pretty simple. Um. So basically, n is 1. So 1 plus 1 is 2. All right. So the first term would be 2 over 1, which is 2. Is that? The second one, no. The second one, that's n when n is equal to 2. So that's 2 plus 1, which is what? 3. Sorry, guys. Yeah, what? Oh my. All right. Take it easy. All right. Okay. Okay. So that for those callers and his wife, I get cut off. All right. So as I was saying, when n equal 2, that's going to be 2 plus 1, which is what? 3. And n is 2 at the bottom, so that's 2. That's the second term. All right?
Sir.
Yes.
Or when I divide it, I got 1.5.
Okay. Give it to me in fraction, not decimals.
Okay.
Just go on the calculator for me. So you can find it in the box.
Just forward back, sir.
All right, guys. Any of you ladies want to take on the rest of the numbers?
Sir, 204.
Hold on, man. Hold on. I want the ladies to talk. Yeah, Kamar?
Yes, sir. Yeah,
I'm not hearing anything from them more so. Any of you ladies want to take on the challenge? All right, come on, go ahead.
sir, 204.
You sure, sir? 2?
Over 4.
You sure?
No, I mean, 4 over 2, sorry.
I can't 4 over 2.
4 over 3.
I 4 over 3, man. Remember say third term, you know.
Oh, sorry.
So down here so gonna have to be 4 and 5.
Oh, yeah. That's me.
So I must say any bottom, you know.
Yeah, this one. Yeah, with that.
So this will be 5
Right.
and
That will be
6.
6.
All right, guys, are we good?
Yes, sir.
All right.
Answer.
Yes.
I realized in the sequence number, like when I was observing the denominator, it's like you're counting down like from 1 to 5, and then it goes on and on.
Yes,
the denominator I was looking at.
Yes, yeah, it's gonna go on and on, you know. It's gonna go on and
Yes,
on.
as well as
Because
the numerator.
as well as the numerator, right. It's gonna increase. All right. What about number 3? What you notice about number 3?
It's an odd number, but sir, the thing is, it's just counting down from
Exactly.
positive to negative.
Or it's decreasing, not true?
Yes, sir.
Look at it, it's going down. All right, it's going down. Yeah.
Sir.
Yes.
It two way number 4. It two way open after bracket letter, so you get it.
You mean the first 2?
Yes, sir.
All right. So n is equal to 1. So 1 plus 1 is 2. So it's 2 over 1, and 2 over 1 is just 2.
Oh.
All right. I guess I should have put it 2 over 1, but I couldn't.
Oh. Me understand.
All right. So as we were saying, question number 3. This sequence, it is decreasing, not true? Yeah, man. In other words, it is converging, basically. Yeah. So it go from big to small, so it's converging. And from small to big, it will be what? Diverging, right? So we'd say this is a convergent sequence. And this will be a what? divergent sequence. All right, because what? Diverge go from small to it just keeps on getting bigger and bigger. This one is also what? Divergent, not true? That's divergent, and this is also what? Divergent. All right, so all right, let's look at this one now. Now this one requires the use of a scientific calculator. I have a calculator, but I don't know where it is, and I can't dig up the place for a calculator right now. But basically, all right, so take out the scientific calculator. Let me see if I can work out. Let me see if I can bring up my calculator on the computer here. All right, so is this scientific? Yeah, okay. All right, so n is equal to 1, right? N is equal to 1. So we have a subscript 1 equal sine of, I'm going to write 0.5, a half, multiplied by n. So the n there, so that's 1, not true? Yeah. Multiplied by pi. So you are going to know. You are going to know. All right, so there are two ways of doing this, right? Now, on your scientific calculator, we have three modes. We have three modes. We have gradient, G, degree, and radian. Let me write it. Anybody have the calculators out? The scientific out with them?
Yes, sir.
All right. Okay. All right. So if you look at the screen itself, you might see grad, deg, or rad, or G, D, or R. Now tell me, what do you see? Tell me if you see a D. Pass?
So I'm not 100% know about this. Is something like second.
All right.
Yeah.
All right. You know what? All right. It's 10:34 now. Let me just wrap up this. All right. All right. Basically, what I'm saying is, if your calculator is in degree mode, pi is actually 180 degrees. All right. But if your calculator is in radian mode, pi is just pi. It means that you don't have to type in 180. Pi is just pi. All right. Having said all of that, I don't know what mode your calculator is in. I'm gonna assume it's in degree mode. So to work this out now, so rather than saying so right here, so we have pi, you're gonna put 180. All right, and I'm basing an assumption that it is in the degree mode. You guys following? All right. All right, so let me try that now. Are you guys seeing my scientific calculator on this on my screen?
Yes, sir.
All right, so I'm gonna have 0.5, 0.5.
So sir, sine now go in a calculator too.
Eh?
Sine now go in a calculator too.
Oh, hold on. I think you know. Hold on. Let me try something.
Sir.
Yes.
Can the class volunteer to send a screenshot of the work because I have workshop.
No, it's recorded in the Travis. All of it is recorded.
Okay, sir. I have to go to the workshop.
Okay. Zedford, I think you have to type in the number for example, we know that sine 30 is 0.5, and true.
Yes, sir.
What I did, I type in 30, then I press sine.
Oh.
So
them alone stay sir.
Yeah. All right. So I'm gonna type in a number first. So I'm doing this right now, right? I'm gonna type in all of this. So I have 0.5 times 1 times 180 equal. Then I press sine. Wait, no, so I get 1, not true? Right. So you get 1. All right. And then you keep on doing it again until you know. All right. So I'm gonna write in the answers for you guys so you can go home. So the other one is 0. Minus 1. 0. 1.
Da, yeah, wala. Pero meron 200% na last time sa calculator na daw ka. Yo.
On 0.
Yep, definitely 1.
All right, so there's a reason why I'm writing more than 6 then, right? Because I want to show a pattern. All right. Okay, so last point before I go, you see, what do you know about these numbers? What do you know about them? Do they go up? Do they converge? Do they diverge? Class? What does converge mean? From big to small, not true?
Sir, the next one. When you
periodic, right? Very good. Periodic means it starts somewhere, but one place and go back to the same place, not true? So as you can see, you have 1, 0, minus 1, 0, 1, 0, and then you go to minus 1. It's like it's going around a circle. All right. So we say this series, not series. This sequence is periodic. All right, class. Okay. All right. Okay. So on Friday, let me tell you something. Sometimes sometimes they give you and this part is the hardest part. Sometimes they give you the number them. They give you the number, the sequence, and ask you to figure out the formula. Yeah man, that part wicked.